So in the previous video, we talked about the central limit theorem for proportions, and we did a couple simulations to kind of see what exactly p hat, which was the sample proportion, what was the distribution of it, and we kind of just talked about it, and we said that p hat was normal, and it had a mean and a standard deviation. The standard deviation is also sometimes called the standard error, so I wrote it right here. Standard deviation is sometimes called the standard error. So just know that this two can be interchanged. And also, in order for it to be normal, it has to be large enough. And what does that mean to be large enough? We need to check these conditions. Okay. All right. There's other conditions as well. Has to be a simple random sample as well. But we're going to assume that all of those sampling methods have already been tested and they're all going to be the same. Otherwise, you can't do the problem. So let's do an example of what would kind of look central limit theorem problem would look like. So here, suppose that about 25% of Mesa College students wear glasses. Okay, so we sample 100 students. So part A says, check the assumptions for the central limit theorem for proportions. I wrote CLT as a shorthand notation for central limit theorem because I don't want to write it over and over and over again. So the first thing that we want to do is check the assumptions. So the assumptions for the central limit theorem, if you can see over here, is this thing that I just boxed. So we need to show that this is true. We need to show that NP is greater than or equal to 10, and also that N1 minus P is also greater than or equal to 10. So you got to check both of this. Okay, so here, what is N? So N in this case is going to be the number of people. In this case, it's 100 students. So N is 100. And P is equal to the probability or the proportion. Okay, so 25, which is 25%. Okay, so it's 0.25. So all we have to do is just plug them into our formula. So we got to make sure that 100 times 0.25, okay, is greater than or equal to 10. Well, in this case, if I multiply this out, I'm just going to get 25, which clearly is greater than or equal to 10. So that checks out. And now what we want to do is check the other one, because the other one might fail. So we're going to do 100. 1 minus p, so it's 1 minus 0.25. This is equal to 100 times 0.75, which is equal to 75, which clearly is greater than 10. Okay, so they both check. So assumptions check. Assumptions check. Perfect. All right. So now that they check, now let's go to part B. So part B says that now because this is large enough, since that n equals 100 is large enough, fill in the blank for the sampling distribution. Okay, so remember that the sampling distribution, you need to find the mean and you have to find the standard error, okay, or the standard deviation. And if we look back, we're just basically looking at this p and square root of p, 1 minus p over n. So let's figure out what those guys are. So first, let's try to figure out what the mean is. The mean of p hat. We know that that's just equal to p. P in this case is just equal to 0.25, so we're going to write 0.25 there. Okay. Then we're going to figure out the standard deviation. Sigma sub p hat. That's just equal to the square root of p, 1 minus p over n. So this is going to be the square root of 0.25. 1 minus 0.25 divided by 100. Okay, so I'm going to put this in my calculator, and what I'm going to get is 0.04. So all we have to do is just plug those in to the fill in the blank, 0.25 and 0.04. This is basically my sampling distribution, okay, which will be used in a little bit. Okay, now let's move to part C. And in part C, it says, find the probability that less than 20% of the 100 students wear glasses. So now since we're looking for probability, we know that this is normal. All we got to do to find probability is just use normal CDF. So let me draw a picture of the normal curve. The mean in this case is 0.25. So the mean is going to go here, 0.25. And we want to find the probability that less than 20% of the 100 students wear glasses. So 20% as a decimal is 0.2, and 0.2 lies here. And we want everything that's less than that, so everything that's less is over here. So we're looking for this probability. Remember that this is just negative infinity. So to find this probability, all we have to use is just normal CDF. My lower bound is going to be equal to negative infinity. My upper bound is going to be equal to 0.2 because that's where this guy ends. My mean is equal to 0.25. And my sigma, my standard deviation, is going to be equal to 0.04. So this is just things that we did in the previous section. So put that into your calculator. Okay, so I'll give you a little bit of time. I've done this already, so the answer here is going to be 0.1056. So that is a probability that less than 20% of the 100 students wear glasses. Okay, so everything is just the same. The only thing that was different was just these two parts. But everything afterwards is just exactly the same because we've already done problems that deal with the normal distribution. Okay. Part D, find the probability that between 23% and 28% of the 100 students wear glasses. Okay. So we're going to go ahead and do a normal curve again. In the middle is going to be 0.25 because that's still my mean. And now we want between 23% and 28%. Well, 23% is right here. Here's 0.23. And 28% is right here. And we're looking for everything that's between. Between is everything in the middle. So we're looking for all of this area. So again, we're going to use normal CDF. So norm CDF. My lower bound, in this case, is not negative infinity because look at the area. The area starts at 0.23, so my lower bound is 0.23. My upper bound is where it ends, which in this case is going to be 0.28. My mean hasn't changed. It's still 0.25. And my sigma is still 0.04. Okay, and when I put this into the calculator, I'm going to get 0.4648. That is my answer. Okay, and now my last question. So find the sample proportion associated with the 30th percentile. Okay, so now let's draw a normal curve again. So my mean hasn't changed, it's still 0.25. Now what we're looking at, my keyword here is percentile. Okay, so we're not looking for probability, we're looking for the sample proportion. So what p hat is associated with 30% being below it. So here we're looking for what p hat is associated with 30% below it. That's what basically the percentile means. And when we have percentiles, we're not using normal CDF, we're using inverse norm. My area to the left is going to be 0.3. My mean is still 0.25, and my sigma is still 0.04, okay? And this is going to give me a sample proportion of 0.23, okay, or 23%. So 23% of the 100 people are the 30th percentile, okay? So notice that these problems are exactly the same thing that we did with the normal problem. It's just that we got to do two different things in the beginning. We need to figure out what our mean and our standard deviation is in the beginning, and also figure out what our assumptions are actually checked out. Okay, so that's how you do these problems. In the next video, we'll do another problem.